Good evening, everyone. My name is Joey Sugarmock, and here we go with the 2023-2024 winter weather forecast. So, as always, when looking at winter, the first thing that we look at is often the Pacific Ocean, a huge driver in the worldwide weather. Always with the Pacific Ocean, you are going to have either a La Nina or an El Nino, or perhaps a neutral Enso phase for your seasons. This year we have an El Nino, which is different from years past. The past several years we have had what is called a La Nina, which is the cooling of the waters off the Pacific Ocean. So where you see this big blob of red, that is the warming of the waters off the Pacific Ocean, a big warm blob here. That is indicating El Nino. Meanwhile, in the past few winters, we have had a La Nina. So this red would be blue, and it's a cooling of the waters off the Pacific Ocean. Again, this winter it is El Nino. And when you have a big mass of warmer than average temperatures, at least when it comes to the sea surface, like you are seeing here in this big area, that fires up convection and thunderstorms. And those thunderstorms and convection will send a lot of heat up into the atmosphere and help dictate where the jet stream is going to set up during the winter seasons. And the jet stream is basically just a pattern going from west to east, and obviously it will dip at some points and lower at other points, and that will have a huge indicator in your weather. Now, going back in history, this is also a very strong El Nino. It's incredibly potent, and you can have a weak El Nino, a moderate El Nino, a weak to moderate, a moderate to strong. This is a very strong El Nino. The same can be said for La Ninas. Very often, going back in statistics, strong El Ninos almost always lead to milder and dry winters for the Northeast. Why? Because oftentimes this warmth here correlates to a lot of warming right on the eastern seaboard by the eastern water, so therefore you have the ocean water influence, and a lot of times it sets up colder air out west, warmer air out east. Not always, but that has generally been the case over the past century. So, but this year it's a little bit more complicated, and it's not as clear-cut as it may sound. So while a strong El Nino, as clearly seen here, does indicate generally a milder winter, a lot of times in an El Nino winter, especially a strong one, you have a lot of cooling in the waters just east of Japan. So it's a little bit hard to see, but here in Japan, eastward, you often have a lot of cold water here. It's the complete opposite this year. There's a huge warm blob out in Japan as well. And there's a ton of warming going on in El Nino. It's not like it's just in the center of the Pacific. There is warming pretty much everywhere. Granted, the further south you go, there is some cooling, but a lot of warm waters going on here. And while that may sound like, okay, the more warmth there is, the more warmth we're going to get, but not necessarily. And sometimes warmth on one side of the continent or on one side of the atmosphere can promote warmth on the other side. Another area that we look at is the area just south of Alaska in the Pacific, and this is what we call the PDO, the Pacific Decadal Oscillation. It is in kind of a more negative phase now. In the past several winters, or I should say the winters where we've had the most snow, it has generally been in a more positive phase. But it is in a slightly more negative phase, not downright bottom negative, but in a more negative phase. You also need to watch what is going on just south of Alaska. When you have a lot of warm water south of Alaska, that would encourage for there to be a negative EPO, which is the East Pacific Oscillation. And a lot of times when you have a negative EPO, you have warmth developing in Alaska, which is a ridge. And a ridge is an area of high atmospheric pressure. Very oftentimes, when you have a ridge in Alaska, you have a trough in the east. So a ridge, an area of high atmospheric pressure, a trough, an area of low atmospheric pressure. So for that reason, when you have a ridge in Alaska, you often get a trough in the east. So as you see, it's pretty neutral right now. Not a ton of warmth south of Alaska, not a lot of cold either. So it kind of leads to a lot of question marks on where the East Pacific Oscillation will set up. Will it be positive? Will it be negative? Will it be kind of neutral? There's not a lot of strong indicators one way or another. Another oscillation that we pay very close attention to is the MJO, which is the Madden-Julian Oscillation. Now, contrary to many other oscillations like the North Atlantic Oscillation, the East Pacific Oscillation, the Arctic Oscillation, where it has a positive and negative phase, the MJO has numeric phases, and each phase, as this diagram shows, has different kinds of weather for different areas of the continent, or of the country, I should say. So, there are 8 phases, and as you see, phases 1 and 2 favor a colder east, a little bit of a milder south, but 3, 4, 5, and 6, particularly 4, 5, and 6 favor colder air out west, warmer air out east. Another part that we look at is the IOD, which is the Indian Ocean Dipole, and has a strong correlation to the MJO. It is in a very positive phase right now, and it looks like it will be that way for the foreseeable future. So because there is a very positive IOD, once again, looking back in history in all of the non-snowy winters and snowy winters we have had, When the IOD is very positive, oftentimes it locks the MJO into the warmer phases, so particularly phases 4, 5, and 6. The most prime example is back in 2019 to 2020, where we had one of the least snowiest winters on record and one of the warmest winters on record in the Boston area. That was one of the reasons for that was we had a very positive Indian Ocean dipole, which locks the Madden-Julian oscillation into the warm phases. So while it may sound like I would be alluding to that happen again this year, it's not quite as conclusive as the past few years, and there is a chance that it does not work out, because oftentimes, while the Madden-Julian oscillation can have a very big impact on our weather, its effects can also be muted, and there have been seasons where the Madden-Julian oscillation is in warmer phases, yet it does not correspond to the troposphere where we live. Additionally, it has also been in the cold phases before, but it doesn't really bring a lot of cold. So it is not the only driver, it is only one, and it is going to be interesting to see where these phases set up and how powerful the IOD is. Despite it being in a positive phase, there are some signs that its effects may get muted, so even if the Madden-Julian oscillation gets into these particularly warm phases, it doesn't automatically mean we're going to be warmer than average consistently. One of the reasons being that we may not be in the warm MJO phases, and one of the reasons that it may not dominate the pattern, is the QBO. So there's a lot of conflicting factors going in both directions. And the QBO is the quennial biennial oscillation, and that pertains to the wind over the equatorial Pacific, over the equator. And the wind is in the stratosphere, which is the second layer of the atmosphere. So it's going a certain direction. It either goes easterly or westerly. Once again, going back into history of winters that were really snowy, really non-snowy, in the middle, oftentimes the snowiest winters have been when the QBO is in the easterly phase. Meanwhile, the less snowy winters have been when the QBO is in the westerly phase. When the QBO has been in the easterly phase, it generally favors colder winters with a lot of storminess and a lot of high latitude blocking. High latitude blocking, more on that in just a little bit, but simply cut, it is ridging and war that gets into the Arctic. In order to get cold down into the lower 48 from the Arctic, you need to get warmth to get into the Arctic to dislodge the cold down south. So, with an easterly QBO, it encourages the chances for more of that high latitude blocking, more of that warmth to lift north and cold air to dip south. So, one of the counterpoints to it being a milder winter is with the QBO being in the easterly phase. Granted, it's not pointing in a super strong direction, as this model shows. It's kind of hugging the neutral line, but it has generally been in an easterly phase. So that would be a counterpoint to a milder winter, because it would like to favor some colder air moving south. And then, of course, everyone's favorite, another huge factor on our weather, is the polar vortex. So the polar vortex is a big current of very cold air way up in the atmosphere in the Arctic. And as this diagram shows, when you have a strong polar vortex, very often a lot of the Arctic air up north is kept there and trapped up north, and it cannot move down into the lower 48. As a result, it allows warm air from the south to move north, so therefore we get generally a more milder pattern, and a lot of storms that go west of the coast because there's no blocking to push it south, so oftentimes they like to go west and what we call inside runners. So they favor, more interior locations for snow and a lot more mixing here locally. Meanwhile, on the opposite side, a weak polar vortex, when the cold air starts getting dislodged and the polar vortex gets more wavy and you have this big swirly line, that is what allows Arctic air to move down south, warm air to get up into the Arctic, and that can lead to big undulations here locally. Not only does a weak or disrupted or perhaps even split polar vortex indicate cold air, it also can indicate big undulations, like big powerhouse nor'easters that could come up the eastern seaboard. It's not a direct correlation, though, and a common misinterpretation is just because the polar vortex gets disrupted or splits does not automatically mean one of the lobes is going to come right over our area. Sometimes what can happen is the polar vortex can split on the other side of the hemisphere, and places like Asia and Europe get a lot of the cold air, but it doesn't really make it down here. And what can also happen is even when the polar vortex splits on our side of the hemisphere, cold air can move south, but sometimes it struggles a lot to come east into the eastern seaboard, into the Boston area. Meanwhile, it kind of takes a deep dive south, and areas like Texas, Oklahoma, North Dakota, the Midwest get the brunt of the cold, but a lot of times here on the eastern seaboard, it struggles to really move east. Not all the time, however. Sometimes it splits and we have a big lobe of cold that goes right over the northeast, and we get some pretty intense cold and storminess. So, when it comes to the polar vortex, it is very much worth noting that models, especially with the polar vortex, are not exactly very accurate, and a lot of times in model runs that you see here that's unfolding on repeat, a lot of times the most accurate is at the beginning. What is the polar vortex doing right now? It's very, very hard to predict the polar vortex out in advance because it really can change on any given day. It's unlikely to go from very strong to all of a sudden splitting, but a lot of times you can only look at the present first few days of the polar vortex. You can't really predict it super far out in advance. Nonetheless, while the polar vortex right now is looking rather strong, which means a lot of the cold air is going to be trapped up north into the Arctic, there are some signs that it may get disrupted or may even split as we head into later December and perhaps early January. Now, again, a lot of caveats to that, because if it does split, where does it split? How big of a split is it? Does it split at all? Is it just a disruption? Is it just a stretch? Is it just a weakening? So that very much remains to be seen, but because there are signs that the polar vortex may weaken as we head into later December, that would indicate better chances for some cold to dip down south into the lower 48 rather than being all trapped up in the Arctic. Meanwhile, this is at the end of the model run here, and it is worth noting that this is indicating a very strong polar vortex. Now, obviously the colors can be very misleading, but in this case, noticing these little isobars here, that might be a little bit hard to see, but it's a very circular polar vortex up north. So what is this indicating? A very consolidated, strong polar vortex. For that reason, a lot of the cold is trapped up north. And also, going back to the high latitude blocking point. So oftentimes, not always, they work simultaneously. So when you have a strong polar vortex, it's very, very hard to get high latitude blocking, because high latitude blocking is warmth and ridging getting up into the Arctic. Thus, with the strong polar vortex, that keeps a lot of the cold around the Arctic and suppresses all of the ridging south, so therefore, there's no blocking to work with. Meanwhile, on the converse side, when you have a weak polar vortex or a disrupted polar vortex, that allows warm air to move into the Arctic, cold air to move down south, so therefore you have a higher chance for getting high latitude blocking, particularly in Greenland. This map is modified a bit for size, but Greenland blocking is a big indicator on our weather. That correlates to the North Atlantic and Arctic oscillation. When you have a negative NAO, North Atlantic oscillation, and a negative AO, Arctic oscillation, that indicates high latitude blocking, and vice versa. Here, while it is indicating a strong polar vortex, it is worth noting that some of this warmth here in Alaska, especially just west of Greenland and into southern Siberia, you notice that it is starting to lift north a little bit. So while this is a strong polar vortex, what this is somewhat alluding to is a stratospheric warming event. Now, the 5 layers of the atmosphere, we have the troposphere, which is where we live, the stratosphere, mesosphere, thermosphere, and exosphere. The only layers of the atmosphere that really matter for our weather are the troposphere and stratosphere. And in order to get cold down in the troposphere, you very often need warmth in the stratosphere to dislodge the cold up in the stratosphere for it to then move south, couple with the troposphere, and give us cold for where we live. Now, the stratosphere, as you head up north, you do notice some warmth trying to get in there. There's no guarantees that it does, but as this warmth slowly starts to lift northward into the Arctic, there is a chance that it may perturb the polar vortex and allow some more cold to move down. So what makes this winter forecast so complicated is that there are a lot of factors moving in opposite directions. Obviously, we talked about the oceans and how they generally are favoring a milder winter for the East Coast. But what about the stratosphere? And what if some cold air some warm air moves into the Arctic, we get a disrupted polar vortex? And also, what happens with the Indian Ocean dipole, and what is going to happen with the Madden-Julian oscillation? That, again, very much remains to be seen. And while it is a strong El Nino setup, some of the other characteristics of the oceans are not totally lining up. Another factor that we look at and kind of we try to extrapolate based on what the patterns are showing us is storm track. So the past several winters where we've had La Nina winters, a lot of times La Nina winters lead to what is called a southeast ridge. So as described earlier, a ridge, an area of high atmospheric pressure. When you have a ridge in the southeast, sometimes it really flexes north and we get a lot of the warmth from the south. Sometimes it gets squashed by Greenland blocking, as that label shows. But this is not a La Nina winter. So La Nina winters almost always love to spike the southeast ridge, especially as the months go on, El Nino winters, not so much. That's not to say there cannot be a southeast ridge in an El Nino winter, but it is not as common as a La Nina. So for that reason, the past several winters, the theme has been that we might get a lot of storms that go west of the coast, kind of come through us. As a result, you get sometimes some snow to start, but we don't usually get all snow situations because it drags in warm air as the storm goes right over the top of us. So we get snow, but then some ice, some rain, some mix, and it just becomes a total mess. And inland is favored for more snow. And that is a La Nina pattern. El Nino, not so much. Rather, you often have a very subtropical jet stream, and it can kind of come down, of course, from the northwest, and then kind of like flatten out as it goes right across the Midwest. So, this is the big question mark here. So, if there's no southeast ridge, it would somewhat lead to, especially if there's Greenland blocking, for the storms to kind of take a flatter track and maybe hit the Mid-Atlantic, very likely so indeed, but it would be somewhat difficult for the storms to come north and hit New England. So, we might see a lot of storms, what we call sliders, storms that kind of go right across the United States, and then kind of flatten out and struggle to come northeast into the Boston area, but they hit the Mid-Atlantic. Especially if there's Greenland blocking, that will kind of squash the storm south. So we might, again, as this diagram shows we might see a lot of storms that try to come north and might graze us, but it might be a little bit difficult to get a lot of storms that come right up over the top. However, another caveat to that is, what do we see in the west? So the west coast oscillations are very important. We have the East Pacific Oscillation, as just described, and the Pacific North American Oscillation, the PNA for an abbreviation. So the East Pacific Oscillation is what's going on in Alaska, and the PNA is correlated to what's going on out west in California and Nevada. Now, if we have a more positive PNA, which is a ridge in the west, that provides a lot of amplification to storms that come from west to east, and that would encourage storms to move further north and give them a little more intensity. Meanwhile, if it's a negative PNA, there's kind of a lack of amplification, so the storm does not have much juice to work with, and it also may force it to either go west or kind of just flatten out and sail out to sea. And then, of course, another question is, how much cold air are we going to have? Because the cold air has to start somewhere. Now, early in the season, a lot of times you need a very good track and a really good precipitation in order to get a big snowstorm, because there's not a ton of cold air around usually at the beginning. Not always. But then as you get into January, like the heart of winter, a lot of times you don't need like an Arctic air mass in order to get a snowstorm. You can have like a marginal air mass. But what really correlates to pre-storm cold air, like cold air there at the onset, is what's going on in Alaska, the East Pacific Oscillation. So a negative East Pacific Oscillation, which is a ridge in Alaska, sends a lot of cold down into the lower 48, so that can provide a lot of pre-storm cold to work with. Without a negative EPO, a lot of times pre-storm cold air is lacking. Now, that does not mean that we would not get snow, but it would be a little bit tougher to do, and you would have to rely on the storm taking a very eastern coastal track and getting enough amplitude so it can generate kind of its own cold air. So for that reason, it's really looking very torn right now on what is going to happen in the west, which will have a big correlation to what storms we get in the east. Thus, so when we get to the month-by-month breakdown of winter weather, so the active storm track, I have no doubts that it will be an active storm track. I think we will have a lot of storm chances. Not every storm will be huge. I especially think that in December it'll be kind of some more lighter events, but pretty frequent. And the question is, so what will happen? I do think we will have a track similar to what was just showed in the picture first, but what is going to happen out west will have a big impact. I think that it's going to be generally a flatter track to start things off, because I don't think we're going to have a lot of amplification from the west. I think we're going to be lacking the cold air as well. With the polar vortex still being strong in December, at least what it's predicted, I don't think there's going to be a ton of cold air to work with. So I think storms will take kind of a flat track, and even if they do make it to the northeast, I think snow is going to be hard to come by because it's going to be a very marginal air mass. It would have to rely on the storm being super strong and taking a benchmark coastal track in order to provide its own cold air and really bomb out. I don't see that happening much in December. That's not to say coastal snow cannot happen in December, but I don't think that's going to be our best chance for snow, and I do think December will be generally warmer than average. Meanwhile, in January, I think we're going to start to turn the page a little bit. Once again, so even if we were to get a polar vortex disruption in mid to late December, effects from the polar vortex would not kick in until at least January, maybe even mid to late January. A lot of times, effects can take at least a few weeks, sometimes even like a month. So it depends on what happens, if it happens at all, and where it disrupts, where it splits. But oftentimes, it takes quite some time for the effects to really kick in. So for that reason, with some disruption to the polar vortex likely as we head into later December, I do think January will turn progressively colder as the month goes on. I also expect that storming pattern to continue. El Nino winters are more prone for there to be bigger storms, like again, bigger undulations. They also encourage more polar vortex disruptions usually. So because of that, we're going to be more prone to have bigger storms. Not so much like the small, moderate events, more of like some perhaps big nor'easters. And I think our best chance of like a bigger nor'easter here that does come up the coast and into New England would be in the second half of January up through the first half of February. And that's going to be our best chance for there to be big undulations around, some amplification getting going from the west, and that would be our best chance to get some rather significant snowfall here in Boston. Temperature-wise, I don't think it's going to be crazy cold, however. While a polar vortex split can lead to sustained cold if it hits the right spot, I don't think we're going to have an Arctic freeze or like a huge ice box come over us. I think there will be enough cold around, especially as the month progresses, for there to be snow even to the coast, but I don't think it's going to stick around for very long. I don't think it's going to be a crazy cold month. It might be a bit below average, but I don't expect it to be way below average. Meanwhile, as we get to February, I think it's going to be very much the tale of two halves. So in the first half of the month, I think that big storm hedge that I talked about in the second half of January will hold its course for the first half of February. Also, looking back to history, in Boston especially, the first week of February has has traditionally been a very stormy week in the winter months. A lot of times we have gotten these bigger nor'easters, these bigger snowstorms, and I do expect that to be the case this year. I think the first week of February, even the second week, will feature several opportunities for winter storms. However, I do not expect that to last the whole month. I think as the month goes on, especially as we get into the second half, the pattern will relax. I think we will kind of shift from a more northerly track that kind of shoots up the coast, more to that flatter track that was described earlier on. Meanwhile, temperature-wise, I think it'll be colder at the onset, so more cold around to work with, but then it'll warm up considerably as the month goes on, so the overall average temperature will probably be near to slightly above average. It could kind of go either way, but I think February will end up a bit warmer than average, but a better chance for cold and snow at the beginning. Meanwhile, in March, which is always a huge wildcard month here in New England, what are you going to get in March? Sometimes March is a total spring month here. We get warm weather, the flowers bloom, no issues. Some years, March is the biggest winter month of the year, and we get feet of snow. What is going to happen this year? I think, again, it's going to be kind of the tale of two halves of a month. So after that mild end of February, I do expect winter to make a little bit of a last gasp in the first week of March. So as obviously, as tradition goes, in like a lion, out like a lamb. I expect that to be somewhat the case here, maybe not quite as symmetrically, but I do expect March, the first week, to be rather stormy. Will there be enough cold air around, though, is a big question, because oftentimes, we talked about earlier in the season where a lot of times you need a perfect track for there to be a lot of snow because there's usually not a lot of cold air around. March, it's kind of the opposite, just on the opposite side of the season, in the sense that, a lot of times the deep cold is kind of moving away, the averages go up, the ground gets warmer, the sun angle gets stronger, so it is a little bit harder to get big snowstorms to the coast in March. Please discard those dings coming in. So, that doesn't mean that it cannot be done, and I do think there will be a shot for one or two bigger storms in the first week of March. So, will it be enough? We will see, but I don't expect it to last. I think in the second half of March, we will officially start the transition to spring. I do expect spring to arrive pretty much on time this winter, maybe a few days early, maybe a few days late, but I think March will be very much a tale of two halves, and as they say, out like a lamb. I don't expect a big storm at the end of March, at least in the form of snow. If we get some storms towards the end of March, it might be more in the form of rain, but I think the best chance will be in the first half. So, the official snowfall prediction for Boston this winter, we are going to go with 40 to 50 inches. The average snowfall in Boston is 43.8 inches, so I'm expecting a very, very average season, near to slightly above, or perhaps near to slightly below. This is a little bit of an aggressive prediction because, again, in these very strong El Nino winters, sometimes winters are snowless, we don't even get 20 inches of snow. However, while we do have a strong El Nino, there are signs that it is going to gradually weaken as the season goes on. It's likely going to peak in mid to late December, but then gradually weaken as the months go on. So for that reason, there would be more chances for snow and cold as the winter goes on. And even within a strong El Nino, those other factors that are going on might kind of play with it a little bit. We might get a polar vortex disruption that might kind of trump the normal effects of a strong El Nino, and there might not be, the ocean waters here on the East Coast may not be as warm as what a strong El Nino sometimes does. So, going to be a little bit aggressive here. I think it's going to be a very, very average season. And then there's the question, so this is Boston, so what happens inland? Because very often, inland gets more than the coast because they're colder, so they don't have to deal with all of the ocean influence, and they don't get as much mixing. While I do think inland will get a bit more, it's just almost always the safest bet, I don't think it's going to be a huge year where there's like so much snow inland and very little to the coast. Meanwhile, I don't expect it to be the opposite extreme, which is 2021-2022, where the coast actually got more snow than the interior. Boston recorded more snow than Worcester that year, which was very, very impressive. I don't expect that to happen this year, but I don't expect inland to have a significant increase in these numbers, because as described earlier, I don't think in La Nina, where we've had a lot of storm chance to kind of go west of the coast and favor inland, I think this year it's going to be more of a slider and flatter track that may favor the coast if there's enough cold air, may favor interior if there's not, but I do see a more coastal track for storms generally this year. And that's not to say we will not have any inside runners, but I do not think they will be quite as common as in years past. So, that's my best guess here. Very curious to hear yours. Really appreciate you all listening to this forecast. We'll see if it pans out. May pan out really well. May pan out really poorly. We'll just have to see what happens. But thank you so much for watching. If you want to discuss any more specifics of this winter, you can please let me know in the comments below. I'd be happy to chat with you there. Thank you all so much, and I will see you in the next one.